The Chinese spacecraft Tianwen 2 aims to collect samples from the asteroid Olwa, which is believed to be a piece of the moon, and bring them back to Earth for study. China has a space station and has successfully landed robotic explorers on the moon and Mars in recent years. Now, the country's space agency has set its sights on a more ambitious goal, sampling an asteroid that may hold secrets about the formation of Earth and the moon. The Tianwen 2 spacecraft was launched on Thursday at approximately 1:31 local time, 21:01 Wednesday Iranian time, atop a Long March 3B rocket from the Xichang Satellite Launch Center in southwestern China. The robotic spacecraft will reach the near-Earth asteroid Olwa, 469,219 Olwa, in about a year. Upon arrival, Tianwen 2 will attempt to gather some rocky materials from the asteroid's surface and then return to Earth. The capsule containing this geological treasure is expected to land on Earth in late 2027 for scientists to recover it. If successful, China will become the third country, after Japan and the United States, to return pristine samples from an asteroid. Yuichi Tsuchiya, a lunar geologist from the University of Hong Kong, told the New York Times, all planetary science researchers in China are now praying for this historic mission. Tianwen 2 also has a secondary objective, to investigate an unusual comet that may be studied in an extended mission. Studying asteroids and comets can enhance our understanding of the building blocks of planets in the inner solar system. Since asteroids may pose a collision threat to Earth, spacecraft that analyze their structure and mineral composition can help design methods for deflecting or destroying dangerous objects. Although pieces of asteroids occasionally reach Earth's surface, they often become contaminated and altered as they pass through our atmosphere. Scientists prefer to extract pristine material from the source and study it in ultra-clean laboratories. According to Ashley King, a meteoriticist from the Natural History Museum in London, sample return missions allow us to examine the physical and chemical properties of an object at such a precise level that is not possible with remote observations by telescopes or spacecraft. Japan has been a pioneer in asteroid sampling. The Hayabusa 1 and Hayabusa 2 spacecraft targeted the asteroids Itokawa and Ryugu, respectively, in 2005 and 2019. NASA's OSIRIS-REx mission also successfully returned a sample from the asteroid Bennu in 2020. The China National Space Administration has conducted 2 successful sample return missions from the Moon, in 2020 and 2024, but Tianwen 2, which means questions from heaven in Chinese, represents China's first attempt to return samples from an asteroid. The target asteroid, Olwa, is a relatively unusual body. Previously known as 2016 H3, it orbits Earth as a quasi-satellite, but because it is gravitationally influenced by the Sun, it is not considered a true moon. Recent telescope observations suggest that Olwa is composed of the same volcanic materials found on the Moon, implying it may be a piece of the lunar surface ejected into space by a meteorite impact. The samples expected to be brought back by Tianwen 2 could help solve the mystery of the origin of this asteroid. China has released little information about Tianwen 2's operations, but a scientific paper published last year provides some clues. A series of cameras and infrared imagers will examine the shape, size, rotation, and mineral composition of the asteroid, while radar systems will map its internal structure. Tianwen 2 will also assist in studying the Yarkovsky effect by examining the thermal characteristics of the asteroid. When sunlight strikes a spinning asteroid, the sunlit side warms up. However, the ongoing rotation cools the asteroid, pushing it slightly backward like a tiny thruster. Over time, this outgoing heat can divert a safe asteroid onto a collision course with Earth. The GAIN spacecraft, set to launch in 2028, aims to collect samples from the surface of Mars and return them to Earth. The United States is also working on a similar project, which has faced significant challenges.